Nashville Systems Programming Day was sponsored by Elasticsearch, an open-source distributed data store with a RESTful API, full-text search, and more. Elasticsearch.org.
Hey guys, thanks for having me. The first thing I want to talk about is the transition from desktop to mobile. So, with C# and .NET and 16 gigabytes of RAM, it got really easy to write desktop apps. You didn't have to worry about RAM that much unless you were doing Photoshop or something that used a lot of RAM. For the average user, they're going to have plenty of RAM in their computer, and so you can kind of get lazy as a developer if you want to and not worry about memory management so much, right? So whenever the iPhone came out, all of a sudden now we're down to, I believe the iPhone 1 had 256 megs of RAM, and you've got all these rich graphics, and really, graphics are some of the biggest things, PNGs, some of the biggest things that you have in RAM, and so we all had to start thinking differently about memory management and really paying attention to it a lot more once mobile came out. We had less RAM and we had a lot slower processors. So before ARC, so ARC is automatic reference counting. So the way that Objective-C works is that each object has a reference count, and that reference count starts out at 1. It can go up and down. You can actually access it. Every object in Objective-C is derived from NSObject, which has a property called retain count, and you should never use it. Don't look at it. What a lot of people have done is they've tried to iterate through, while retain count greater than 0 release. So retain, release, and auto release were the pre-ARC things that you would have to do. And so basically you're giving hints to the operating system about how this object should be used, how long it should stay around. So whenever Apple moved to the LLVM compiler, or LLVM and the Clang static analyzer, they were basically, you could run the static analyzer, it would go through your code and show you places where you might have memory leaks. And so they thought, well, instead of they had thought about doing a garbage collector, but the problem with the garbage collector on mobile is that, depending on what your app's doing, your heap might grow, really fast, and all of a sudden, if you have mail and all these other apps running in the background, even on an iPhone 5S, with the Giga RAM, you're still going to end up filling up your heap, right? And so at some point, the system's going to have to come through and clean all that up. And at that time, you're going to get a second or two delay, which Apple hates, right? So they want everything to be fast and smooth. And so that's why they came up with ARC. And so what ARC does is ARC actually goes through and statically analyzes your code and looks at all the places and infers where it retains and at compile time inserts, retains, and releases and auto releases in all the correct places. So that's why Apple chose to go with ARC versus garbage collection, because they thought it would be better for performance for the user experience. So in ARC, you have strong and weak variables. So a strong variable obviously is retained. A weak variable can be blown away. And the interesting thing about weak variables in Objective-C in ARC is that they're zeroing weak references. So what that means is that if, let's say that you have a class that has a delegate property. So it has a delegate and it's going to call back some delegate methods on this calling class. Well, if you create the property for that delegate as a strong reference, then you're going to create a retain cycle, because this object, this object is now the delegate of this object, but this object is retaining a strong reference back to this object, and so when this thing gets dealloced, its reference count won't ever get to 0 because the thing that it's holding has a reference count of 1 on it. So what you have to do is always make sure to declare your delegate properties as weak. So what that'll do is that if it was a non-zeroing weak reference, what would happen is that if the delegate object went away and you try to call it, you'd just be hitting some random spot of RAM and the app would crash. So with the zeroing weak reference, what that's awesome for is that if you have a delegate property set and that delegate goes away, then that'll be, once it goes to 0, it'll actually turn into a null or a nil. And in Objective-C, you can send any message to nil and it doesn't do anything, so it's not going to break your code. There's probably some code smell there if that's happening, potentially, but that's something that you want to try to avoid. And you also want to be a good memory citizen. So whenever you read the Apple documentation, pretty much everything, they say you can request this from the operating system, but you're not guaranteed to get it, right? So, you know, there's application did receive memory warning messages that fire whenever your app's starting to use too much RAM. And so Apple sends you these over and over and over again saying, come on guys, come on, like get rid of your RAM, get rid of your RAM. And if you don't do it, they'll just kill your app because they're not going to let the phone reboot. So being a good memory citizen means, you know, really it's based on your architecture. So, and this is, CoreData is one of the important parts of the iOS SDK, because with before CoreData, when iOS 1 came out, CoreData didn't exist on the iPhone. But so basically you had your whole object graph in RAM, and then you would have to either write your own serialization code to handle when you wanted to pull stuff in and put it out, or you would just have your whole object graph in RAM. And for Riposte, actually, for app.net, which has mostly text, we use an image cache for that. But since it's mostly text, our Riposte doesn't actually use CoreData. It uses, we wrote our own data model for it. And so, but we have our whole object graph in RAM. And so once we started adding multiple accounts and we started adding, you know, people started getting more and more posts coming in, then all of a sudden we ran into this problem where on startup we were getting like, you know, it was taking like 5 seconds to load the app at start because it was having to deserialize the whole object graph from disk back into RAM, which you don't really want. And so what CoreData allows you to do is CoreData will, it basically faults objects. So if you have your data model defined in CoreData, whenever you go to, you know, if you have 20,000 tweets, right, to pull up, well, CoreData basically just saves metadata about the fact that there are 20,000 tweets. And so it can, so then you can hook a bunch of stuff up to your UI table view, and then you know, okay, you know, there's a number of rows at index path, right? That's a delegate callback that you pass back the number of rows that you're going to have in your table. So now you can pass back 20,000, but you don't have to have all 20,000 objects in RAM. You have 20,000 faults. So it loads the minimal amount. It's like a really light object, and then at runtime, whenever one of the properties needs to be accessed on that object, CoreData will actually go, and it's a little bit more complex than this, but it basically goes and grabs the data at runtime when you need it, and then you can actually call a method to then refault the object back once it's done. So that's really what being a good memory citizen is about. And also whenever you hit the home button on an iPhone, the app actually doesn't close, it gets suspended in the background. It has about 3 to 5 seconds of time from the time somebody hits the home button to when the OS is going to kill the main thread. So, you know, there's a UI application delegate callback that's application, you know, will enter background or didn't enter background, and you can request more time, ask the OS for more time if you have stuff that you need to do, like finish downloading a file or finish doing some processing. In the instance of CoreData, doing a save operation, like it's up to you to make sure that like you're handling that. So that's really, I guess, kind of really high level, you know, the history of iOS memory management. So now, you know, avoiding retained cycles is super important by using weak references when necessary. Another way that you can, you know, they also added blocks to Objective-C a couple of years ago. And blocks are basically just closures that you pass in and that get called back later. And so if you reference self inside of a block, that's going to automatically be a strong reference. And so now you're going to have, let's say that I say, you know, download this file, right? And I pass a strong reference in. Now inside of that block, it's actually making a copy of that block and then holding a strong reference back to the original class that was created in, that self was called by. And so when that happens, now you have a retained cycle. And there are a lot of cool, really great tools for debugging this kind of stuff. There's instruments. You can use leaks and allocations in Xcode to see, you know, run your app and see what your app's doing. See, is your RAM going up? Like, what's the heap doing? You know, is there a memory leak? There are also kind of deep buried down in the settings of Xcode, some stuff to turn on as something for zombies, which are basically like lost objects that there's not, like the object's not dealloced, but there's no reference to it anymore. But it still has a reference count, but you're not actually using it. So zombies can catch you, but you can flip on something that'll basically it'll hit a breakpoint anytime that there's a zombie object created. There's also guard malloc, which you can turn on, which basically prevents you from, it basically says, memory barriers around your application code so that you're not writing over an array or something like that, writing off the end of an array. And so there are a few cool things like that that you can use. And there are a lot of great articles out there about, they go deep dive into a lot of this stuff. Mike Ash is a guy that I would check out his blog. He talks about zeroing weak references and a bunch of other stuff. And there's still some tricky things because all the Objective-C and Cocoa stuff is all fully ARC compliant, but all the old core foundation stuff that are C methods is not ARC. Well, it's not ARC compliant out of the box. You have to basically give hints to the OS about. It's called bridging, and it's too detailed for this topic, but this talk right now. But basically, what you can do is you can give hints to the OS so that it can kind of marshal back and forth between like the older style stuff and the ARC stuff, and it knows what to do with it. But since the release of ARC, it's been a lot easier for developers. It's basically probably cut, I don't know, 25% of the text out of source code because you don't have all these retains, release, auto releases. So, in a nutshell, that's basically the history of iOS memory management. Does anybody have any questions? All right, thanks, guys.